We begin now with the adiabatic process. We have already seen the isothermal reversible expansion as well as irreversible expansion, then the irreversible compression of gas. Coming down to the adiabatic process, we see that it is a process that occurs without transfer of heat and mass between system and surrounding. Heat is converted to work, but that is all going on inside the system. It is almost an isolated system with a with a surrounding. Boundary, of course, it is having, but there is no exchange of matter or energy between the system and the surrounding. As a result, the temperature of the system may increase or decrease. Therefore, internal energy increases or decreases. Now, adiabatic heating or cooling is observed even in nature. When I told you the internal energy decreases or increases within the system, that means the temperature within the system is increasing or decreasing. When it increases, we call that adiabatic heating. When it cools or when it decreases, then we call it as adiabatic cooling. The very classic examples of these two processes in nature are the Chinook winds and the lenticular clouds. So, how do these happen in nature? It is just that there is no exchange of heat in the column of hot air that has risen already over the mountain top, and now once the water vapor has been condensed, the rest of the matter inside the adiabatic system gets heated up, that is, and the temperature rises and it comes down in the form of hot winds down the mountain on the other side. These are Chinook winds, which are actually descending warm air, and as they move down the slope, it is but natural that the speed of these moving air will be very high. Next, we see these lenticular clouds where there is adiabatic cooling. That is, the shape of the cloud itself assumes like a saucer shape, and these clouds are happening. Why? Because inside the air column which is rising above, there is cooling, as the molecules, they tend to convert the extra heat energy into work, and what happens is that they rise higher up, then the water vapor is going to condense into these cloud particles, or you can say into the cloud. The water vapor is condensing, mixing with the dust and forming the cloud. Wherever there is air, that is inside the system itself, inside the column of air, there is dust particle as well as water vapor. So, these water vapor condense and they mix with the dust particles, form the lenticular clouds, and then the rest of the air again moves forward. So, within the system itself, there is work being done due to heating, as we have seen Chinook winds, and due to formation of lenticular clouds due to cooling of the system. Now, what is the work done in an adiabatic process? Like we know that in the isothermal process, we make use of the equation of state PV is equal to nRT. But in case of adiabatic process, the equation is PV raised to gamma is equal to a constant K. Gamma is equal to Cp upon Cv, a ratio. Cp is equal to specific heat capacity at constant pressure. Cv is equal to specific heat capacity at constant volume. And you can see here that the expression of work then becomes W is equal to K, that is this constant, into V final raised to 1 minus gamma minus V initial raised to 1 minus gamma, the whole divided by 1 minus gamma. Again, the relationship between Cp and Cv can be obtained from the mathematical expression of the first law of thermodynamics as well as the equation of state for an ideal gas. Now comes the first law of thermodynamics, which We are waiting for so long. The different statements are there to express the first law of thermodynamics in the physical form as well as in the mathematical form. We shall see the physical statements. Energy is neither created nor destroyed but can be converted from one form to another. The energy of the universe is constant. The total energy of an isolated system is constant. These are three statements, each of which form the first law of thermodynamics. Now, Planck's statement is, it is in no way possible either by mechanical or thermal or chemical or other devices to obtain perpetual motion. Mathematically, the first law is given as du is equal to dq minus pdv. What is u? U is internal energy, q is heat, and p is the pressure of the system, v is the volume of the system. dv shows the change in the volume of the system. Analyzing each term, what is du? U we said is internal energy, but U cannot be measured. U is also represented by E in some cases. U is not a measurable quantity, but du can be measured with respect to other parameters in the system. What is U? U is the internal energy, which is the sum total of potential energy and the kinetic energy of a system. Potential energy is equal to energy in atoms plus energy in molecules plus nuclear energy. Kinetic energy is equal to the rotational energy plus the vibrational energy plus translational energy of the constituent particle. It also includes the chemical energy. Internal energy is therefore an extensive property, and it is also a state function. How to estimate internal energy? I told you absolute value of internal energy U cannot be measured. That is, we say U has got no absolute value. But then how do we measure U? We find U in terms of change in internal energy. It depends on the amount of heat absorbed or given out by a system and the amount of work done by the system on the surrounding.